Hello everyone, myself Akshat Singhal from branch Triple E IIT Guwahati and my roll number is 200108071 and this is my video assignment and my topic is expectation of a continuous random variable. So let's get started with our question. So our question is about viewpoint IIT Guwahati. So let's read it. In recent days, it has been seen that the students of IITG are sneaking in to the viewpoint despite of the fact that it is closed due to COVID-19 restrictions. Let the continuous random variable x denote the time in hours at which the students try to sneak in. The probability density function for x is given by f of x is equal to x divided by 36 for x changing from 0 to 6 hours, that is at night 12 hours to 6 hours. As we know that there is a chances that the guard will sleep at night, so there will be higher probability of students sneaking in at night. So the function will be linearly increasing from at night 12 to morning 6. So our function is good here. So and the second function, that is from morning 6 to night 12 hours, and as we know that the guard will be active at morning because he will be not sleeping at that time, and the chances of students sneaking in at that time will be tending to 0. So our function will be exponentially decreasing, and our function is 1 by 6 multiplied by e raised to the power of 0.3325 multiplied by 6 minus x. So now the admin wants to know who all are not following the protocols and are sneaking in and will penalize those students. So to catch those students, guard wants to know the expected time at which they sneak in. So we have to calculate the expected value of the random variable x. So let's get started with our solution. So let time in hours be x, and x is a continuous random variable with a probability density function f of x. We can draw the graph of f of x with as we know that the f of x is equal to x divided by 36 for x 0 to 6 hours, and 1 by 6 multiplied by e raised to the power of 0.3325 6 minus x for x changing from 6 to 24. And as we can see in the graph, there are two parts. First part is 0 to 6 and it is colored with red, and the second part is exponentially decreasing, as we know that the probability of students sneaking in at morning to evening will be very less. So the graph is exponentially decreasing, as we can see in the graph with the color of green. So as we see from the graph that the probability density function is continuous throughout its domain. This implies we can integrate this function, and the expectation of any continuous random variable x with probability density function f of x is given by Ex is equal to integral with limits minus infinity to infinity x multiplied by f of x multiplied by dx. Since our probability density function is defined between time 0 to 24 hours, that is in a day we as we know that there are 24 hours, so our limit for the integral will be 0 to 24 only. So now calculating the expectation, e of x is equal to integral with limit 0 to 24 x multiplied by f of x dx. As we know that our function is divided into two parts from 0 to 6 and 6 to 24, so our integral will be broken into two parts. So that is integral 0 to 6 with x multiplied by x upon 36 multiplied by dx plus integral 6 to 24 1 by x multiplied by e raised to the power of 0.3325 multiplied by 6 minus x multiplied by dx. So now calculating those two parts, our first part will come out to be equal to 2, and our second part, that is integral 1 by 6 x multiplied by e raised to the power of 0.3325 multiplied by 6 minus x dx with the limit 6 to 24 will come out to be 4.4821. Adding those two, we will get our final expectation to be 6.481. Therefore, the expected time at which the guard should check for the students should be approximately at 6.481 hours in the morning. So that was our final solution. So this is all with my video assignment. I hope you have liked the question and the procedure of my solution. Thank you guys.